pat myself on the back here. Nice job, Todd. So let's first go over homework number 2. I think that's probably the most pressing order of business. Then after we get through this, we'll just kind of open it up for general questions. I can talk a little bit more about the exam for tomorrow if you have any questions, and then we'll be done. You can be on your merry way to study. So, all right, homework number 1. Let's go through this kind of question by question. I'm going to show you my key. My key is actually, or at least it's kind of a partial key. Wait, sorry. So I don't have a ton written down. Gosh, dang it. Don't have a ton written down here on the key, but I hopefully have enough that we can kind of use this and we can work through these questions together. Okay, so first off, consider the simple model of production with the Cobb-Douglas production function. Here, the main difference is that you notice the coefficients are 1/2, 1/2 instead of 1/3, 2/3, which is what we usually use. Calculate the equilibrium wage and rental price. So for part A, in equilibrium, remember, the wage is equal to the marginal product of labor. And what is the marginal product of labor? It's equal to 1/2 Y divided by L. If you plug in L, you can simplify it down so that the real wage is equal to 1/2 times A times K divided by L to the 1/2 power. And here is the formula for the rental price of capital, which is once again equal to the marginal product of capital, which is equal to 1/2 Y divided by K. If you substitute Y in, you can simplify down to this. So we actually did this exact exercise in class. The only difference here is the coefficients are 1/2, 1/2 instead of 1/3, 2/3. Do diminishing marginal returns hold for this production function? Yes. Diminishing marginal returns say that when the quantity of an input goes up, the marginal product of that input goes down. So if we look at, for instance, the marginal product, right? What's happening to the change in output as one input changes? So for instance, if we start with 1 unit of capital and 1 unit of labor, what's output? 1. If we then increase capital to 2, what happens to output? It goes up by 0.41. If we increase capital by 3, it goes up by 0.32, whatever, right? In other words, you see that the change in output is getting smaller here as the level of capital goes up. That's what diminishing marginal returns means. You could have also shown this by just taking this marginal product up above and just showing that, for instance, when L goes up, the marginal product goes down, right? So you could have done it that way too. But when I say, show this, I really was asking for you to do it mathematically, right? So don't just say, well, there's diminishing marginal returns, so it holds. You're not really explaining why diminishing marginal returns holds. What does equilibrium output look like in per capita terms? Here you just divide by L, and so this is equal to A bar little k to the 1/2 power, right? So once again, we essentially did this in class. The only difference is that your coefficient is different. And then finally, what happens if you have an increase in A? An increase in A increases your production function. So this would shift up and it would increase the marginal product of capital and the marginal product of labor. So in both cases, the labor demand and labor supply would go up. That would increase R and that would increase W.
Can you go back up to C really quick? I'm sorry.
Mm-hmm.
Thank you.
Yeah, sure. And I am, by the way, recording this. So if there is some things that you miss or you feel like I'm moving too fast, by all means, slow me down. But also, I'll send you out the link and you can go back and skim for little pieces if you need to hear it again or just miss something. Okay, during the Spanish flu outbreak in the 1900s, between 2 to 3% of the European population died from it. So based on your knowledge, what should have happened to wages in Europe? Well, actually, we could just go up to this previous production function. Notice here that what happens when L goes down, what happens to the marginal product of labor? It goes up and the wage goes up. So, listen, 2 to 3% of the population dying isn't all bad. We get higher wages. Celebrate, right? What happens to the marginal product of capital? Well, here when labor goes up, notice the marginal product of capital goes down, okay? So capital and labor are complements. When you have less when you have less labor, it makes capital less productive. And so when labor goes down, the marginal product of capital goes down, so does the rental price of capital. Okay? So, based on your knowable, sorry, this should be based on your knowledge of the simple production function, what should have happened to wages in Europe as a result of these deaths? Oh, I'm sorry, that's the part we already answered. And then B, could you attach a number to the extent? Oh, I'm sorry, hold on. Guys, what? Is your mom can't talk on the phone? I hate to do this. This sucks. Can you hold on for a second? There's somebody at the door. Everyone's going nuts. I'll be back in a second. All right, sorry everybody. There is no intruder breaking into our house. I think the kids thought there was somebody that was trying to rob us. I don't know exactly what they were trying to rob us of, but anyway, okay. So anyway, part B, could you attach a number to the extent of the increase in the wage? Yes. Think about this, right? Our marginal product here. If L goes down by 3%, it's essentially the same. Oops. It's the same as adding here 1 divided by 0.97, right? So how has wages changed? It's changed by 1 divided by 0.97 to the 1/3 power, right? 1 divided by 0.7 to the 1/3 power, or 0.01, or about 1%. So in other words, wages should go up by about 1% if the population goes down by 3%. Okay? So you might guess why I asked this question. COVID sucks and a lot of people are going to die, but we all might get a little wage increase. Isn't that exciting? I'm not nearly that cynical. I just have to play an economist in class. Okay, question number 5 from chapter number 4. I think most of us had no problem with this. If there was a mistake, I actually tried to just copy and paste this formula into your answers or into your homework so that you could refer to it back. So basically what you needed to do here is you needed to use, you need to calculate per capita GDP, the predicted, right, based on what formula? The formula that we derived up here before, right? That per capita output is equal to A times K. You want to use 1/3 in this example and not 1/2, right? So that's the answer that you use. And when you do that, you assume that A is equal to 1. And then in the third column, you want to try to figure out, well, what would be the A that would lead the predicted to be equal to the actual, right? And so what's the takeaway from this? The takeaway is if you assume total factor productivity, is constant across countries, you are, for almost all countries, way over predicting what their output is. Because what's true, most countries do not have the same total factor productivity as the United States does. So if you assume it's the same across countries, you're really going to over-predict. And so this is very similar to what we talked about in class, right? I mean, we talked about just this thing, just this idea in class, just in a little bit different form.
Quick question about the one you just showed.
Yes.
For future homeworks, can you put like the first sentence of those book questions? Because certain platforms have different numbers for the questions.
Yes, and you know what? I did not realize that until somebody said they had an Amazon version of the book that was slightly different. So yes.
So do I.
Okay, I'm sorry. I actually had no idea about that. So yes, I will do that in the future. And sorry to create that confusion. I have no idea why. And you have the 5th edition, Cole? It's not the 4th edition?
Yeah, no, it's the 5th. I made sure of all that, and I called the bookstore to make sure it was the right thing. It was just a different format. But
okay, yeah, I have no idea why that is. But yeah, I won't do that anymore.
Like for which one was really, I think it was either this one or the other book question for number 9.
Mm-hmm.
There was either 2 5s on those pages, or there was, like, I think it was this one, but this one was actually number 6, not number 5.
Okay. Well, I will try to be a little bit clearer. And next time, if I use a question from the book, a little bit clearer about what it is.
Well, honestly, all you'd need to do is just put like the starting sentence.
Sure.
Or something like that, or,
Yeah, sounds good. In fact, I think all of these questions have a little title. So I'll just include the title of the question so that you know what it is. But yeah, sorry about that. I had no idea why some of these are different than others. Okay, question number 5. So here's basically a numerical version of the Solem model, like we did in class, right? Where you first have to calculate what the steady state level of capital is, and then given a current level of capital, you have to figure out what's the change in capital. Okay, so how do we figure out the steady state? You set delta K equal to 0, right? Where we use that formula that we talked about in class. So actually, I didn't actually write the formula here, but I have it written down here below. Here, let me type the formula in. So you said delta K equal to 0. So that what is delta K? Right? This is delta K. S, there should be an A in here too, right? So S times the production function minus D times K. So S bar times A times K to the 1/3 minus D times K should equal to 0. You then plug in for S bar, which is 0.2. You plug in for A, which is 2. You plug in for D, which is 0.15. And you set that all equal to 0. And when you solve, you should get 4.355. When I looked at this, I tried to distinguish between making a math error and making an error of understanding. And that's something I will try to do on the exam tomorrow too, right? Is math errors happen. I make them quite regularly, in fact. And so if you make a math error, that's probably going to be a minor reduction. But if you make an error in understanding, that's going to be more important. right? And so, so that's how you do part A, is just set our equation for delta K equal to 0 and solve for K. Now, in part B, the current level of capital now is given to you as 6. So calculate the change in capital and output next period. What's the change in capital 2 periods from now? Does your answer make sense? So here, you basically want to figure out what delta K1 is, knowing that K0 is 6. Okay, so you plug in 0.2 again, and you should get negative 0.5964. Okay. And so what does that mean that capital next period is going to be? Well, if it's 6 this period, and it goes down by negative 0.5964, then it will be 0.54635 next period. What about for 2 periods from now? You do the same thing, but now for the capital stock, you use 5.4635 instead of 6. And what do you find? You find that it goes down by 0.457. Does this answer make sense? Yeah. Right, let me just do a little solo diagram here. So here's our solo diagram. And so in part A, we calculated that the steady state here is roughly 4.3. But where are we starting out? We're starting out at 6.0. So what should we be finding? We should be finding that we have negative growth. In other words, the change in K should be negative here. But what's going to happen to the change in K as we get closer to the steady state? The change in K should get closer to 0, right? The change in K should get closer to 0. So that's what we found in this answer. Notice that we have a negative change in K, but that change in K is getting closer to 0 as time goes, okay? And so, yeah, these answers should make intuitive sense, right? They do make intuitive sense.
Would it have been okay for like to prove the intuition or intuitive sense part there if we just solved for the drop period, so like the negative 0.59 and then the negative 0.46 to prove that they're both negative and getting closer to the steady state?
So I don't understand your question, Cole.
So like on mine, I ended mine with like when I solved for like your first change in K1 and then delta K2.
Mm-hmm.
So that's what I solved for, and then because of that, I knew it made intuitive sense because they were both negative, meaning they were getting closer over time. I didn't solve for the, well, for my first part, I didn't solve for the 5.4635 until the second part in order to find that drop. That's still okay, correct?
Yeah, I mean, really, when I say, do they make intuitive sense, I'm asking you to put some words to this and explain what's going on. So I'm not, intuition doesn't mean, you know, the math is one thing, but then use a couple of words to explain to me that you understand what's going on here. And also, this leads to a big point, that let's say that you screwed up the math somehow and you got a positive number here. If you, at the end of this, said, you know what, I got a positive number, that doesn't make any sense, I think I've screwed something up. That is a very good answer to me, right? Like even if you screw something up math-wise, but you know that it's not right because your intuition is strong, that is going to get you a lot of credit, right? It's going to get you a lot of credit. And so I think that's really what I was asking is just, you know, forget the math. Can you explain what's going on, right? does your answer make sense to you? Okay, question number 5 here. This is a tricky question, right? No doubt about it. I have to give you at least, oh, by the way, if I can just say something about question number 4, I don't want to give you too many hints, but this is a good kind of question for an exam, right? So, given that we did it in class and you did it on the homework, that should be a pretty good indication that I think these are the kind of questions that you could possibly see in tomorrow's exam. Speaking of questions you could see on tomorrow's exam, this is a question that I just pulled off an old exam. So consider a solo economy with a capital stock of 300 billion and a balanced growth capital stock, or in other words, a steady state of 500. So what happens to this country if they're given a one-time gift of capital? So the steady state is 500 billion, and this country is way below its steady state. It's down here at 300 billion. What happens if this country is given 100 billion in capital? Well, some of you said, well, it changes the savings rate, but the key to this is a savings rate means it's a permanent increase in how much you save. But this question is very clear. It's not a permanent increase in how much you save. It's just a one-time increase in capital. So essentially, what's happening is instead of being down here to 300 billion, it's just moving us to 400 billion. So what happens? Output goes up, but strangely enough, growth actually goes down a little bit because we're closer to the steady state. And so this gift, while it does increase the level of output, it actually reduces growth. And it doesn't change anything in the long run. In the long run, we're still going to be at the same steady state as we were before. What about part B? Well, part B says, now assume sorry, having graphing problems here. Now assume that we begin at 500 billion and we're given 100 billion so that we move up to 600 billion. What happens now? Well, now notice this has moved us above the steady state. And so what would happen in this case? Actually, output would go up, but then immediately output would begin to fall. And we would have negative growth in this case because we are above the steady state. And so what does this tell us about aid? That aid is unlikely to permanently increase a country's income level. And it might stimulate growth in the short run, but it could also decrease growth in the short run, right? And so this is why economists in general are not huge fans of just giving, aid just willy-nilly, right? I'm not saying that aid can never do any good, but if you don't have the proper institutions, and if you don't have, high savings rates and the other things and high productivity so that you can make good use of the capital, right? If you have poor institutions and you just give a country aid, a lot of that aid is just going to be wasted, right? And so economists, once again, I don't want to sound too grinchy here in the Christmas season. I'm not saying that economists never think that aid is a good idea, but we tend to be pretty skeptical. In many ways, if a country is doing well, that's the best country to give aid to, but that's probably also the country that least needs it. And, kind of counterintuitively, the countries that need aid the most are also probably the countries where aid is going to be the least effective. Okay, so that was a question that was really kind of asking you to distinguish between, the short run and transition paths versus what impacts output in the long run, which is a change in your steady state. Any questions about that one? Like I said, I would say that's a little bit harder of a question, right? Because it's kind of It's taking what we talked about in class, but asking you to extend yourself just a little bit. Okay, this is, next one is question number 2 from chapter 5. I think I'll do this one on the iPad. I thought this question was pretty straightforward. Hopefully you find it that way too. So here we are in our steady state, and then we use a specific example of China that has a big increase in A from technology transfer. How does that change the Chinese economy? Well, an increase in A is going to shift up the production function and move us to a higher steady state. And so what's going to happen in the short run, everybody got that graph? Okay. So then what happens, I think if the question asks to what happens to the level of output, what happens to output? It goes up in the short run, and then it's higher in the long run. And what happens to growth? Well, remember, growth starts at 0. And then what happens when A goes up? Growth jumps positive, but then it goes back to 0 in the long run. Okay, so we were at the steady state before where growth is 0. Then when you have a one-time increase in A goes up, and then we go back. It slows down over time as we get closer to the new steady state.
Quick question.
Yeah.
Why couldn't we show the jump, kind of like how you did in the graph right above the growth for output?
Why don't we have a jump?
Well, no, I'm saying why couldn't we put, so like we start that baseline for the short run on 0, kind of like how you did, and we just show the jump straight up like that. How come that's incorrect?
I guess I don't really quite understand your question, Cole.
So if you made your growth look like the graph above it for output, but you started it at that 0, and you showed the jump going positive for growth, and then going back to negative or zeroing out, why would that be wrong compared to the growth graph you drew?
So are you saying, what if you did growth like this? Yeah, but that's not right? Because if we started at 0, you're saying that growth is permanently going to be above 0. That's not what happens in this model. In this model, growth eventually goes back to 0. Okay? So output, the level of output permanently changes, but the growth rate only changes temporarily. Okay, does that answer your question? Okay.
Yeah. I made mine like the last graph you did. I made mine curve back down to 0. So it just showed it was it grew, but then it fell again. I didn't draw the jump point from it starting at the peak and declining. So yeah, I see where I messed up.
Okay, I can't really remember exactly what you did, but if you think I missed something or whatever.
Oh no, I know what I did now. I didn't put that jump point. I actually drew the line in the graph to show it reaching the jump point. And now I get what you're saying, how that's wrong.
Okay, good. All right. Moving along slowly. Here to question number 7. So here's the Romer model, very much like we did in class, right? Very much like we did in class, but here we're just asking you to put some numbers to it. So you're told that A bar is equal to, or that A bar in times 0 is 100, that L bar is 0.1, the Z bar is 1 divided by 3,000, and the N bar is 1,000. What's the growth rate of knowledge in this economy? Well, I have a lot of things written down here, but the growth rate of knowledge, remember, in the Romer model is just Z times L times N. And so if you multiply that out, you get 0.03333, or 3.33%. Okay. What's the level, for part B, what's the level of per capita output in this economy? Right. So first off, we have to figure out what A is. And what's A going to be in year 5? It's going to be A in year 0 times 1 plus G to the 5th power. Well, actually, I'm sorry. This is a mistake. That should be Y. What did I do here? Yeah, sorry. Not sure exactly what I'm. Let's do it up here. I think I've got some typos in here. Sorry. So what's output in year 5? It's equal to A times 0 times 1 minus L times 1 plus G to the 5th power. If you multiply that out, I've got a lot of typos in here. I'm sorry. It should be it's something close to 107. You will get much different answers depending upon how much you rounded for your growth rate, right? So I know some of you use 0.03 and you get 104, and some of you used a bunch of 3s and you get a bigger number, okay? So, but this is roughly depending upon how much you rounded. What's the growth rate of output? In this model, the growth rate of technology is also the growth rate of output. So you can see here that A and Y grow at the same rate. So if A is growing at 3.3% a year, then output is going to grow at 3.3% a year. Okay, and then finally, no, not finally, forgot, we have question number 9 too. Here's the data from Young regarding growth accounting, right? And so we're given data on how much output has changed, how much labor has changed, how much capital has changed, and then this is the labor share, right? So instead of using 1/3 and 2/3, I want to use these numbers. So 0.16 and then 1 minus 1.6, or 1 minus 0.61 would be the share of capital, okay? So for Hong Kong, what does this look like? Our growth accounting equation should be the growth of Y is equal to the growth of A times alpha times the growth of L plus 1 minus alpha times the growth of K. Right? I didn't write this very clearly. Let me show you from the notes. Let me show a better way of writing this. These are all the things that would be so much easier if we were doing this in person instead of doing this on a screen. Here we go. So this is really the equation that I'm using, right? Where here's the growth of output to labor. That's, in this question, 147.2, okay? I'll just add this in here. 1/3, we're not using 1/3 here. We're using 1 minus 0.61, or 0.39 times the growth rate of capital, which is 159, plus the growth rate of labor times the share of labor plus the growth rate of A, right? The growth rate of A. And so how do we solve what the growth rate of A is? We just, sorry, this is going to be really annoying. All right, we have, there's an electrician in our house, and one of the things he's trying to do is fix the doorbell. So every time he rings the doorbell, the dog starts barking. So apologize. Timing is never great. So this is essentially how you calculate the growth of total factor productivity for Hong Kong. And so if you do this, what do you find? That total factor productivity grew by almost 52% in Hong Kong. What if you do the same thing though with Singapore? You found that in Singapore, total factor productivity grew negatively. That's a real kind of shocking conclusion, that total factor productivity growth grows 52% in Hong Kong, it grows negatively in Singapore. What does that say about the future of growth in Singapore? Worrisome, right? Because what this suggests is that Singapore is only growing by increasing labor and capital. And if it's only growing by increasing labor and capital, it's going to hit diminishing marginal returns very hard. But if Hong Kong is growing because of productivity, that suggests longer term growth, right? That suggests more possibility for longer term growth. Of course, you notice this paper was back in 1990s. I'm not so sure that this is true today. Just to kind of talk about a current events thing recently, you might have all seen what's been going on in Hong Kong, where China is trying to make Hong Kong look more like China. And the more that Hong Kong looks like China, the more that you would think Hong Kong is going to have the total factor productivity growth of China. And that's worrisome, because there's some real evidence that total factor productivity growth in China is much slower than it is in Hong Kong. And so, there's kind of reasons to be skeptical whether Hong Kong is going to be quite the growth miracle that it's been in the past. All right, and then finally, question number 9. If you remember, this is the question that asks about Earth and Mars. And if I remember the question right, the only difference between Earth and Mars is that Earth has twice the number of ideas. Okay? So let's think about what this would look like. And I'm going to put this on a ratio scale. And for many of your graphs, or when you do a graph like this tomorrow, you need to make clear whether you have a ratio scale or levels, okay? You need to make sure whether you're using a ratio scale or levels. Because obviously that's going to completely change what your graph looks like. So here we have Earth, and here we have Mars. Notice that Earth is going to be twice as rich as Mars at the beginning. Why? Because it has twice as many ideas. So in the simple Romer model, if you have twice as many ideas, you're going to be twice as rich. But the thing is, these two countries have the same growth rate. They have the same Z, they have the same L, and they have the same little l. So they're going to grow at the same rate. In other words, on a ratio scale, this is going to be linear growth, okay? But the key here is ratio scale, right? What's happening in terms of levels? If you just graph the level of this, in terms of levels, they're exploding. But notice that Mars is going to explode less quickly than Earth because Earth starts with so many more ideas. So in other words, you actually get divergence here. That over time, Earth and Mars will have bigger differences in income levels, even though they're growing at the same rate, okay? So to put this in another way, consider, let's say that I would be as lucky to have the same return on my money as Jeff Bezos has. We both get 5% on our wealth. What's going to happen to our wealth differences over time? They're going to get even bigger than they are today. Why? Because my wealth is growing at 5%, but the problem is I have much, much, much lower wealth. He's getting 5% return on $1 trillion or whatever it is, okay? So in other words, differences in levels are going to get bigger and bigger even if we're growing at the same rate. So I think there was some confusion in this graph. One of the points of confusion that I really want to emphasize is you got to be clear whether you're talking about level scale or if you're talking about a ratio scale, because that's going to fundamentally impact what your graph looks like. Okay? Okay, so there we are. That took a long time to go over that, but we did it, all right? So does anybody have any questions about homework 2? Anything that maybe I skimmed through a little bit too fast or? So are we all clear about what's happening on the exam tomorrow? That be looking on your email. You don't have to get on Zoom, okay? But be looking in your email at 9 a.m. sharp. I will send you the exam. I'm going to give you till 12 o'clock. Feel free to do some writing on a piece of paper and just try to take a picture and put that into your exam if you find that works. Or if you're good at typing, do that. I wish that this was, I wish this was easier. I think, taking particularly in a class like this, really one of the reasons I most wish we were together is quite honestly, it'd be a lot easier to give exams, right? So anyway, but we'll try to do the best we can. I very, very much want to encourage you though, to think about your time management, okay? So don't spend 45 minutes on one question. Don't spend 45 minutes on a 5-point question or you're gonna get in trouble over time. So on the exam tomorrow, there's gonna be 4 big questions, but each of these are gonna have subparts. The 4 big questions, I've kind of written to take about the same amount of time. So I would not spend more than 45 minutes on any one of these big 4 questions, right? So, you got 4 questions. If you spend 45 minutes on each of them, that's 3 hours. So I would really encourage you to have a watch and to not spend too much time on any one question, right? If you get it all done and you want to go back and check things out or add more later, you can. But for most of the answers, I really think that I'm only looking for relatively brief answers. So there is no essay question on this exam. And so if you feel like you're writing an essay, you're probably writing too much, right? So manage your time, be succinct, read the question, right? I know that's kind of pedestrian advice, but in my experience, one of the most commonly made mistakes that students make during exams is just simply not reading questions, getting too antsy to start writing. And so, read the question, think a little bit, and then begin to write, but make sure you don't spend too much time on any one part, right? And so for all of these questions, there's no single question that's going to make or break you, right? There is no true question that's going to be worth 30 or 40 points. So, there's 4 big answers, there's going to be a lot of subparts. And so if you get stuck on something, don't be afraid to leave it and move on, right? Don't be afraid to leave it and move on. I think that will be a good strategy so that you don't get too bogged down and find yourself with 15 minutes and still half the exam to go, right? What else? Do any of you have any questions? Yeah, Carson.
Will we have class in the afternoon?
Thank you. No class tomorrow afternoon. It's the exam seems like plenty enough work, right? So I'll send you out a to-do list, but on Thursday we will talk about, what is that? I think chapter 10. No, actually, what, I can't remember, but I'll send you out. But yeah, no class Wednesday afternoon. So recoup a little bit and get ready for Thursday. So during the exam tomorrow, I will stick pretty close to my computer, right? So if something happens or you have a question, you can send me an email. You could also Zoom me, send me an email before you Zoom so I turn on Zoom. But if you want to talk, if you feel like that would save you time, I'm happy to talk to you on Zoom. But I'll be around for questions, right? So if there's anything that you're unclear about, yeah, I will be around. Any other questions? Robin, you mentioned that you had a couple of questions about homework number 1.
Yeah, I was just, if no one else has any other questions, I liked how you went through homework 2 just now. And if you could just quickly go over like the key for homework 1 as well, that would be really helpful.
I don't know that we have enough time to go over all of homework 1, given it just took us 45 minutes to go through homework 2. But I am happy.
Okay.
By the way, if all of you don't want to stick around, you can drop off and go. But I'm happy to I pull up homework number 1 again, and if you have some questions, I mean, I did, Robin, go through all of homework number 1. I can't remember what day that was.
Okay.
Friday afternoon.
Oh, okay. So I
Yeah.
can go back and watch that. Okay.
You can.
Yeah, that was.
Right, you can. So I tell you what, maybe I would suggest, let's do it this way. Why don't you go back and watch that video if you weren't here Friday afternoon. Go back and watch that. And then if you have specific questions or things that I didn't talk about, or I talked about too quickly, send me an email and we can either talk on email or we could do a quick Zoom tonight.
Okay. Yeah, thank
Okay.
you. I had to take care of a sick person that day, so I didn't realize that you went over it.
And you know what? I remember that you emailed me. Yeah, we're all good. We're all good. Okay. All right. Well, good luck tonight. And like I said, if questions come up, you need something desperately answered, yeah, send me an email. I'll be around tonight. Okay. Thank you, everyone. Good luck.
Quick question for you after.
Yeah.
So for number 8, like you were showing in class, and so I was using that same formula for the, hold on, let me pull mine up, for the growth accounting that you were showing.
Mm-hmm.
Same one you were just showing in class there.
Mm-hmm.
So, and like that one, it was growth rate of K minus growth rate of L, to the 1/3, and then
Right.
plus, and then another one.
Mm-hmm.
How come we didn't do the subtraction there?
So if you remember,
Oh, I'm sorry, go ahead.
okay, so hold on, let me just.
So I rewatched the videos and I could not find you talking about, well, like I found us talking about like that and then how to solve for TFP and all that, whatnot, but I just could not find how you set it up there in class or how you just showed it to us.
Okay, so let me pull up my notes. So these are the notes from chapter 6.
Yeah,
So,
right there.
right. So we took growth accounting. So if you start with a simple production function, you put it in per capita terms. So L here is the population, right?
Mm-hmm.
And so if you then simplify it, you get this. And then if you put it in growth rate, this is the growth rate of per capita output, the growth rate of per capita capital, the growth rate of labor force relative to the population.
Mm-hmm.
Okay. And then the leftover is total factor productivity.
TFP, yep, that we have to solve for, yeah.
Right.
So what I was wondering is, like, I understood, like, obviously, like, we were not given the population. So the LT we were not able to actually solve for. But, like, so in that equation right there, like the 1/3 growth rate of capital minus growth rate of LT,
Mm-hmm.
were we supposed to just assume that this was what the percentage change that we were given already was already the capital minus the population. Were we just supposed to assume that then?
Yeah, well, yeah, I mean, I guess. I mean, without giving the information, you can't include it in here, right?
See, yeah, that's what was screwing with me because like I could not figure that out for some reason. And I ended up doing it a different way at the end there. Well, how you show like the 1 minus alpha, I ended up just infusing that in my. I kind of set it up like you did,
Mm-hmm.
but but for that base formula you were showing us there a little bit ago, like I just could not figure that out for some reason.
Yeah, well, I mean, you're right. I mean, I guess maybe I probably could have written this question a little bit clearer because I didn't mean for you to be spinning your wheels thinking about where's the growth rate of population.
Well, no, I mean it's not that big of a deal. I only think I missed 0.25 on it, so nothing to. But I was just wanting to know for tomorrow. Obviously, that's why I'm just asking.
Right. So yeah, I mean, I think on your homework, Cole, you were close on a lot of things, but just some small mistakes. And in part, I took off points just because I want you to be aware of.
Oh no, like, I don't mind. I mean, I think I did the math. Each homework's only worth like 2.1% or something like that of our overall grade. So I mean,
The most important part is you get it right on the exam. And that's exactly why.
Exactly. Yeah. No. Yep.
Homework is so. Yeah, you got it on the exam. So.
I don't care about missing too many points like you're saying on the homework there. 10